Yes, you can turn around. Yes, sure. That's the ultimate option.
Ladies and gentlemen, please take your seats as we're about to begin our next session of the plenary, and we'll be discussing chemicals and plastics in this session. Please come in and take your seats. I'd now like to invite the moderator for this session, Ms. Sandra Averus, from the Chemicals and Health branch of UNEP, to start the session. Over to you, Sandra.
So thank you, everybody. And welcome to this session on chemicals and plastics on this Solutions with Science Day. So we'll try to state the issues associated with chemicals and additives in plastics, as well as present some solutions. As you know, the urgent need to address actually marine plastic litter and microplastics is now widely recognized. The damage that plastics are doing are often visible and dramatic. What is less apparent is the risk associated with additives and chemicals in and on plastics. There are many chemicals that are being used in the production of plastics, and you will hear of a number of them today, ranging from monomers that help to make the plastic polymer itself, and a lot of range of additives that are added, for example, to soften plastics, to provide a color, or to make the plastic less flammable. They are very useful, and their functionality are useful, but they have a potential to contaminate the soil, the air, the water, the food, and it's widely documented in the literature. So we will explore this issue today. And I would like to welcome the panel and thank the panelists for coming and trying to enlighten us on this topic. I would like, first of all, to call Professor Shige Takeda from the Tokyo University of Agriculture and Technology to come and share his presentation.
Okay, thank you, Sandra, for your kind introduction. I'm very glad and honored to be here for my presentation today. And this shows the outline of my talk. I will start with hazardous chemicals, especially the additives in marine plastics and their transfer to biological tissue. Second topic is the landfill leachate as source of additives to aquatic environment. So chemicals in marine plastics have two origins. One is the hydrophobic chemicals sorbed from surrounding seawater, and another one is the additives compounded into plastic products. The sorption of the hydrophobic chemicals has been demonstrated through International Pellet Watch of our project, a kind of microplastics that is plastic resin pellets are sent from world volunteers, and they are analyzed for persistent organic pollutants, POPs, in our laboratory in Japan. Here we have the analytical results of the PCBs in pellets on world beaches. Height of green bars indicate concentrations of PCBs in the pellet on the beaches. They basically reflect legacy pollution of PCBs. They are higher at the west and east coast of the States, Japan, and Western European countries. In addition to soft chemicals, additives are also detected in microplastics in marine environments. They include phthalates for plasticizer to soften plastics, and also the nonylphenol as antioxidant agents. Also, triazole and benzophenone type UV stabilizers to reduce their photodegradation in the environment. And also we add the brominated flame retardants such as PBDEs and HBCDs and DPE. Problem is that some of these additives are endocrine disrupting chemicals. Additives are broadly categorized into two groups. One is hydrophobic ones, another one is hydrophilic. I will discuss hydrophobic one first. Hydrophobic additives such as BD209 are migrated into plastic matrix, and therefore they are hard to leach out of plastics with water. Therefore, they are retained in marine plastics and carried in marine environment. Actually, we detected relatively high concentrations of BD209, a kind of hydrophobic additives in microplastics in surface water, in coastal and offshore water around Japan. So these results are consistent with the theory that hydrophobic additives are hard to reach out to water and retained in microplastic in the ocean. However, oily components in digestive fluid facilitate the leaching of the hydrophobic additives such as BD209. We examined several types of solvents to test the leaching of BD209 from plastic where BD209 was compounded into. In case of distilled water, seawater, and pepsin aqueous solution, no leaching was detected. On the other hand, fish oil and stomach oil accelerate the leaching of BD209. Stomach oil is oily components derived from the diet, that is fish, and commonly found in digestive tract of variety of seabirds. This suggests that fatty or oily component in digestive fluid facilitate the leaching of hydrophobic additives from plastics. This would lead to transfer and accumulation of additives in biological tissue. So to demonstrate the transfer of additives from ingested plastics and their accumulation in the biological tissue under environmentally relevant conditions, we conducted semi-field feeding experiments of plastic. First, we made polyethylene pellets to which 5 additives are compounded. BD209, also the 4 UV stabilizers, UV326, UV327, UV328, and also BP12 was compounded into the plastic resin pellet. Polyethylene powder and authentic standard of these additives were well mixed and melted and molded into pellets using the extruder. We repeated this process 3 times. Therefore, all the additives are well migrated into plastic matrix. By using the plastic, we conducted the exposure experiment. We had the exposure group and also control group. For the exposure group, we fed the additive compounded plastic resin pellets to the chick of strict shearwater. The experiment was conducted outdoor. Therefore, the parent birds fed their natural food to the chick. And we had the control group where no plastic were fed and only natural diet was fed by parent birds. Sixteen days later, chicks were euthanized and dissected, and adipose was analyzed for the additives. In the control group, we found no or very trace amount of additives. But in the case of the exposure group, we found much higher concentrations of additives were actually detected. This result clearly demonstrated that additives were transferred from the ingested plastics and accumulated in the internal fat of the seabirds. Our study indicates that hydrophobic additives are hard to reach out in seawater and carried to the biota, but once they are ingested by organisms and encounter with the oily digestive fluid, the additives are reached out and transferred and accumulate in the biological tissue. So let me move on the hydrophilic additives. An example is bisphenol A. We visited landfill sites in tropical Asian countries and collected leachate. The study countries include Cambodia, Laos PDR, Thailand, Vietnam, Indonesia, Malaysia, Philippines, and India. Our analysis of leachate from landfill site demonstrated that high concentration of the additives, that is nonylphenol and bisphenol A. Among the additives, bisphenol A showed very much high concentrations, reached milligram per liter range. BPA is compositional monomers of polycarbonate or epoxy resin plastics, and degradation of these plastics may occur under conditions in landfill garbage. That is the high temperature in acidic or basic conditions. The degradation of these polymers may produce the monomer bisphenol A. Another source of BPA is BPA used for additives for the other polymers. Let me show you a case study in Tokyo, Japan. We have the landfill site in upper stream area of river, and which this river runs through the capital city, Tokyo. Landfill was already stopped, but before stopping, we disposed large amount of plastics in landfill. Leachate is still running, and they are treated and discharged to sewer, and treated leachate is carried to public sewage treatment plant and treated again. Therefore, the leachate is double treated. However, BPA is not perfectly degraded or not perfectly removed by sewage treatment system. Finally, we found high concentration of BPA in the leachate, in the sewage effluent from the STPs, and they pollute the whole rivers. This means that plastics we dumped in the past still contaminate the river. This is a kind of legacy pollution. We have to learn something from this legacy pollution. Okay, finally, we reach the conclusion. The hydrophobic additives are retained in marine plastics and microplastics. Leaching of hydrophobic additives is facilitated by oily components in digestive fluid. Accumulation of additives in biological tissue was confirmed by feeding experiments. Landfill leachate contain extremely high concentration of the endocrine disrupting chemicals, that is the additives or degraded monomers. Thank you very much for your attention.
Thank you very much, Professor. So by endocrine disrupting chemical, Professor Takada was referring to these chemicals that actually can cause cancerous tumors or can cause birth effect. So he did demonstrated that they sometimes link directly to the water, or they leak to the animals, or potentially then human body through the digestion system. I would like to call upon, thank you very much for sharing this important and recent research with us. I would like to call upon Dr. Roland Weber, who's already up on the stage. He's a chemist, and his research is focusing on persistent organic pollutants, POPs. He will share with us an overview on additives and plastics.
Yeah, thank you, Sandra, for invitation. Good afternoon, everybody. The talk is about status and potential solutions for chemicals of concern in plastic. The study is together with colleagues from the Technical University of Denmark, and at the moment we have a consultancy for UNEP about additives in plastic. What we saw with the presentation of Professor Takada is that this marine pollution, plastic pollution, at the same time is a chemical pollution. So therefore, when we talk about solutions on the plastic additives, it's also about reduction of plastic. This means restriction of plastic bags, restriction of single-use plastic, phase out of microplastics, and at the same time, we reduce the chemical pollution. One thing I would like to highlight is here the philosophy of late King Bhumibol of Thailand, because he is supporting the sufficiency economy. And this is just the opposite of the consumer society, because actually what we see with our plastic pollution is an outcome of the consumption society. So a big part of the solution could here be starting from Thailand, the sufficiency economy. We had Africa this morning, and there is one champion in Africa in respect to plastic reduction. That's Rwanda. You see with Rwanda, the imports of plastic over the last 15 years have decreased considerably. These are plastic products. And also the import of primary plastics have decreased in recent years. While in other African countries, here this is an example of Morocco, but this is in all other countries in Africa about the same. Here, the plastic consumption is increasing linearly. That's from our paper we recently published. And here, Rwanda demonstrated that with bans, restriction, and strict enforcement, this kind of reduction of plastic is possible. Rwanda is specific, so they have a quite strong political enforcement, and in a study I found at the same time they have a weak plastic industry in Rwanda, and so therefore there is no big counter lobby. But by this you see you can really have an outcome. The second part of the solution is circular economy. Considering the waste crises, and this is not only plastic waste, and the limited resources we have on Earth, we need to move to the circular economy. And when we are moving to the circular economy, we have to ask, what is then with the fate of hazardous chemicals we have put in products in the past? Because when we go circular, these chemicals again show up in new products. So therefore, when considering to move to a more circular economy, persistent organic pollutants, but also other hazardous chemicals, need to be controlled and phased out. So we have a huge amount of additives in plastic. So plastic is actually out of two parts. One is the polymer. Polymer, for example, PVC or polystyrene, polyethylene and polypropylene. And then we have the additives. And these additives, for example, in PVC can be up to 50-60%. So they can even be more than the polymers. Also, when we talk about the PBDEs in flame retardants in a television at your home, it can contain 20 to 25% of the PBDEs. So a large part of the plastic bag can be these kind of chemicals. Overall, there are 9 major types of functional additives. This is a survey from the European Chemical Agency. We have here flame retardants, pigments, antioxidants, and in average, single plastic contain in average 6 and more of these additives. Showing what kind of trouble these additives can make, I take the example of polybrominated diphenyl ethers. These are flame retardants which are listed in the Stockholm Convention for global phase-out. And what we have seen over the last 10 years from research community is, for example, there was a study in South China in children toys, and in all children toys these flame retardants have been detected. This is a friend of mine from Toronto University, Miriam Diamond. She checked her kitchen tools, and in her salad servers she found 1000 ppm of the PBDs and 300 ppm of lead. So with the oil you extract the PBDs, and with the vinegar you can extract the lead. This is a coffee cup from Europe, and there was an investigation here on the coffee cup lids, and also in a large share of these coffee cups the flame retardants were found in up to 1000 ppm here, and so with the coffee you extract here the flame retardants. So what we see is that we have really challenge on these additives, especially in the informal sector in developing countries. But we have a second challenge, because now the PBDEs are restricted, and at the moment in the Basel Convention we have 2 limits suggested. Because there were a fight between 2 parties, one was the European Union and industry, and the other were developing countries and NGOs. So at the moment we have suggested low pop limit of 1000 ppm and of 50 ppm. And if finally 50 ppm would be chosen, the recycling of e-waste plastic at the moment is hardly possible. So therefore we see first a need of a better life cycle management on control of these plastic in recycling, and we see a need of a non-toxic alternatives for clean material cycles. And in the next slides I wanted to go into these two topics. So first to the clean material cycles. These are pictures from the largest plant for recycling of e-waste plastic in Austria. What you see here is that when you recycle here the e-waste plastic, you really can make benefit. In total, they have about 10% of consumption of energy compared to virgin plastic, only 10% of water consumption. And of course, this material is increasingly growing and actually a cheap and available resource. So they do the separation, and finally their product is about similar to the virgin product. So it can go back again to electronics, which would be the aim. Actually, there are about 4 or 5 of this type of plants in Europe which can do that. And these are listed in the Stockholm Convention but BEP guidance for PBDEs. So we have already a global guidance about how to treat this e-waste plastic, how to separate, what are the separation technologies. But actually, still, these companies can only reach about a limit of about 100 ppm of PBDEs. So also for these state-of-art facilities, if 50 ppm would finally be decided for the Basel Convention as low pop content, these facilities would need to close. Also, the informal sector can do this recycling and separation. This is a study from the Swiss Empire in India. So here, the informal recyclers are separating plastic with quite simple tools, but very effectively. 10,000s of tons of e-waste plastic are separated in this way, but finally, they are not separating the contaminants. Also, they could. So by a simple last step of a sink and float, they could take out these flame retardants, but it's not required. There is no legislation, so therefore they just give it in this raw form to the recyclers, and finally these flame retardants end up in the coffee cups in Europe. Another solution for this problem is the so-called Creasolve process. In this process, plastics are dissolved in solvents, and afterwards the polymer and the additives can be separated. So this process can be used for e-waste plastic, but for e-waste plastic we up to now only have pilot plants. For the construction EPS, XPS containing hexabromocyclododecan, there is now the first full-scale plant built in Europe. Also, this facility could separate PVC, polyvinyl chloride, and the DEHP, which is prohibited, for example, in Europe. But also for this, until now there is only a pilot plant, but at the moment a large million project to also develop a full-scale plant. And also for plastic composite packaging, there is one full-scale plant now in Indonesia where plastic packaging is kind of separated and the polymer again recycled in the original use. Coming to the substitution. When looking back to substitution history, we stay with the PBDEs. We see that these PBDEs were often substituted by regrettable chemicals, which were also not much better. For example, the low chlorinated brominated diphenyl ether were often substituted by high brominated DKBDE or hexabromocyclododecan, which also then later on were listed as POP. So at that time, there was a voluntary phase-out concluded by the US EPA, by the Western industry. So the Western industry stopped it, but in Asia, the production was continued, and it's a very cheap product. So the products are price competitive or even more competitive than the alternatives. And when DKBDE was listed in the Stockholm Convention, many exemptions were granted, including also flame retardant in electronics. So therefore, in 2015, we wrote a paper about this regrettable substitution, where we said, at the moment when we look to phase out agreements, it's often voluntary by some producers or countries. It should be binding and cross-sectoral on regional and best global level, like, for example, the Stockholm Convention. Then, when we look to the alternatives, often there was a pre-selection of known and similar substances, because then you can just drop in the alternative, that's more simple. So what should be done is to look functional-oriented design and also to look to structural different substances. And very important is a good assessment of the alternative. Up to now, this alternative assessment were often incomplete or burden shifting, and our recommendation is that an alternative assessment should be complete and should consider the life cycle impacts. And there are already good tools on alternative assessment. Here is the strategy from Ken Gazer from Lowell Center on Sustainable Production. He recommends first identification of chemicals of concern, then select priority uses, identify alternatives, characterize alternative, compare the alternatives, and score them. And actually, for the last process, compare alternatives and score alternatives, there are many tools. One here from the German EPA, another from US EPA, and from other institutions. So what we have is the tools are there. Important, and what is missing is capacity building. Capacity building also in developing countries, but also the European Chemical Agency 2 years ago said there is too less capacity in Europe in respect to alternative assessment. And then the next step, when we have selected a good alternative, important to bring it into products. So here, especially in the design phase, to substitute hazardous substances by more sustainable solutions. And to do this, to do the alternative assessment, the first important step is doing a compilation. So here we have at the moment a process ongoing in Europe from the European Chemical Agency. The European Chemical Agency have looked what kind of plastic additives are used in Europe. Those additives which are used in more than 100 tons per year. And they have found that they are about 418 substances. But, wait a moment. Not covered in this assessment are monomers, polymers, cross-linkers, and transformation products. So what we have done in the activity for UNEP is we have looked also to other sources of plastic additives and have compiled in our report a list of more than 1,300 chemicals in additives based starting with the ECHA overview, including the database of chemical associated with plastic packaging. There's a very good review article, so if you are interested in this topic, you should look to this Gro et al. Paper. Then other studies from academia and plastic-specific consumer product studies, for example, from Denmark, EPA. And what we have done for our report, we have done an overview on substances of concern to start with the substitution, flame retardants, per- and polyfluorinated substances, phthalates, bisphenols, nonylphenols, heavy metals, polyaromatic hydrocarbons, biocides. And we have also looked to the priority areas to substitute, including toys, packaging, food packaging, medical devices, textiles, building materials. So we have already a good case study, that's the Stockholm Convention. In the Stockholm Convention we have additives in plastic listed, and there has been also a guidance developed on alternative of the substances. And so here we have one example where on global level we have a substitution of additives in plastic. And I think this we can use as a case study and then enlarge. And here the question is if other additives of concern could be addressed within SciChem. Therefore, last slide, efforts for a way forward. The first is the understanding that we have many hazardous chemicals and groups of chemicals of concern which are used in plastic as additives for a range of purposes. We have an ongoing compilation and assessment of these additives from Europe, but also currently on UN level. We have in the Stockholm Convention already a process on substitution and phase out of the first additives in plastic. And we have a range of restrictions and substitution of additives on national level or, for example, on European level. Also, several emerging policy issues of SciChem, strategic approach of international chemical management, are related to plastic additives, for example, endocrine disrupting chemicals, hazardous chemicals in the life cycle of electronics, chemicals in products. And so here, this could be a start, possibly, to address this issue and challenge of global plastic additives and how to reduce the hazard from it. Thank you for your attention.
Thank you very much. One point to highlight is that ECHA, the European Chemical Agency, has been providing a set of slides which we incorporated in this presentation. So if you're interested in having further information on the additives that ECHA listed, we can make this set of slides available. Thank you very much, Roland, for the presentation and for highlighting the complexity of the world of chemicals. Luckily, there are conventions. So you mentioned Stockholm, you mentioned Basel. The SciChem process is looking into its beyond 2020 future. There are certainly opportunities for addressing chemicals in plastics. I would like to call upon Dr. Chang, who will be presenting specifically on PBDE in plastics. So you heard about this already, but she will focus on the work in China and on the region, as she's from the she's Chief of Regional Chemical Management Branch in the Basel Convention Regional Center for Asia and the Pacific. Thank you.
Thank you, Chair. I'm Chen Yuan from Basel and the Stockholm Convention Regional Center. So just now, the two experts have gave very comprehensive report on PBDE. So I'll focus my presentation on the activity which implemented by the centers. Okay, first of all, my presentation is polybrominated diphenol ethers, which is call it PBDE in short in plastics. In fact, it's not only in plastics but in products. Okay, next. Oh, this one. Okay, first of all, I'll introduce briefly of the two centers. If you have participated in the Conference of Parties to the Basel, Rotterdam, and Stockholm Convention, you know the regional centers. There are 16 Stockholm Convention Regional Center and 14 Basel Convention Regional and Sub-Regional centers globally. BCRC China, BCRC and SCRC China, the two centers are based in Beijing, China, which, according to the Conference of Parties to Basel, Rotterdam, and Stockholm Conventions, all the centers should be assessed by the Conference of Parties each 4 years. In the last two times, in 2015 and this year, the two times assessment, which Basel Convention Regional Center and Stockholm Convention Regional Center in China which score 100 scores, which are the first place in the world. Just now, the two experts mentioned the PBDE. In fact, because we all know they are POPs, because they have the POP characteristics. In 2009, two commercial PBDEs are listed under the Annex A of POPs Convention, which is penta and octa BDE, which include the tetra, penta, hexa, and hepta BDEs. These BDEs, we can see this figure. It's widely used as a flame retardant, widely used in the plastics, textiles. The plastics are widely used in the electrical and electronic plastics, and the cars, or the airplanes, and the textiles such as the carpet, the curtains. Yes. Yeah, because it has the characteristics of POPs. The octa, penta, and deca BDE all listed under the Annex A of Stockholm Convention, which should be phased out to produce and use. Here I listed, since its production from 1970s, there are actions or regulations on its phase out globally. BCRC China has implemented some projects on PBDE cooperate with UNEP or BRS Secretariat. This project, I'll take the China Trust Fund project, which named as Capacity Building of Environmentally Sound Management of PBDE and their waste in selected Asia-Pacific countries. In this project, we mainly implemented 3 activities. Activity 1 is do the analysis of the feasibility to separate the BDE flame retarded plastic waste from the waste flow. And the second is the public awareness raising materials. And the last one is establish a platform on PBDE, its knowledge. In fact, for this project, we, BCRC China cooperate with Dr. Roland. We do the training in different countries, Pakistan, Sri Lanka, and Cambodia in different years. And here we establish a platform on PBDE. Another one is the technology on PBDE separation technology. In fact, in China, the industry usually use 2 kinds of methods. One is dry method, the other is wet method. For the dry method, it always use the light separation. For the wet method, because we know different plastic have different densities. If the company use the liquid with different density, the plastic will be separate because they will float at different level. The last one, I think, it's China characteristics. Many experienced workers from the plastic recycling industry, through their touch or look, the plastic, they can know if the plastic is flame retarded or not, or which kind of plastic it is. The last one, I just want to mention the Sino-Norwegian cooperation project on capacity building for reducing plastic and microplastic pollution. This project was funded by the Norwegian government. It will be launched. Kickoff meeting will be in the early of next year. This project will have six components, and the partners Norway have 2 partners, and the China side have, besides China as the main executing agency, and we cooperate other 3 partners to do this project. I hope during the implementation of this project, we can have your comments or suggestions or contributions. Okay, thank you.
Thank you very much. And so you see that we can come to solutions when we dig into a specific chemical, actually, like PBD. There are more than 1,300 that have been screened in the ongoing research that is being developed for UNEP. So there's a lot of work to do. I would like just to introduce the 4th panel member who will not give a presentation but will be our main panelist for an upcoming question. So it's Dr. Nguyen Han Thuan. He is an environmental expert from the Vietnamese Environment Administration, and thank you very much for joining us as well. Let's stretch a little bit and let's take our mobile phones, please. We will be looking into a couple of questions for the panels, and at the same time we thought it would be nice to ask you questions as well. So if you could log in to menti.com. So MENTI, so if you press play, you can press play. And the Mentimeter in blue. Mentimeter in blue. Just below the small hand. So you can go to menti.com on the web, if you're all connected to the Wi-Fi. Enter menti.com, and then you're asked a code. The code is 660716. And so as we're asking questions to the panel, we will be also asking you questions. So can we go back to the main? You can click on the eye on the side, on the eye on top, yeah. Yes, oh, someone already responded. So the first question to you is, at what stage should the issue of chemicals and additives of concern be addressed in priority? And you are allowed to pick 2 out of the 4 if you want. There will be 2 other questions, and we'll see it moving while discussing with the panel with question and answer. So, we had a question actually related to this phase. 2 questions, one more on the design and one more on the recycling. So from a design perspective first, what are the implications of these additives in plastics in your experience? And what would be the proposed solution? Is it doable to phase out chemical of concerns? Professor Takada?
Yes, so far we believe the hydrophobic additives are not reached to aqueous media, such as the water or some drinks. But some recent studies indicated that such hydrophobic additives could be finally bioaccumulated and may come to human. And so far, many countries regulate additives by using the leaching test, especially for the food packaging. But I think the leaching test is not enough to regulate or control additives. We have to test the whole contents of the additives in the plastic products, especially the food packaging. That is my suggestion. We have to change the leaching test to the compositional test for food packaging additives.
Thank you, Roland.
Yes, I mean, as I already said, we see at the moment in the Stockholm Convention where we have two very important additives. This is the DKBDE and the chlorinated paraffins, which are plastic additives. And I think many developing countries have asked for exemptions. Also, there are alternatives already available. And I think we should look to this process and how to solve it and support developing countries which think they are still in need. And then by let's say, guiding this process, we should make these two case studies, how to solve that developing countries often think they don't have an alternative, also there are already alternatives available. The other is about this regrettable substitution, where I said, I think what would be important is a global capacity building on alternative assessment. Here the IOMC and the Stockholm Convention have compiled these tools on alternative assessment, so this could be communicated and let's say also educated, like for example from regional centers. And I think you have developed, when we did this substitution of chemicals, you have developed also on your website these kind of tools which are there, but there were no trainings, so we only did the website. Mm-hmm. Then one thing I would like to add is about the many different type of plastics. So it's not only the additives, but also the different type of plastics. So in electronics, we have more than 15 types of basic plastics. So afterwards, it's a huge difficulty in recycling. So if here the producers would come and decide on a few plastics, it could really solve the problem. And maybe a last addition is often we are highlighting what chemicals are toxic and should not be used. But there would be also the possibility to make a positive list. This means what additives are okay. And in Europe, we have for the food contact materials this kind of positive list. And maybe this kind of positive list could also be extended to other plastics. So I think this would be my inputs to this question.
Thank you. And as we are discussing about the design phase, it seems that the design is actually the higher up in the responses of the room. Maybe one point, I mean, I think we know that to take care and to recover marine plastics from the sea is actually likely to be more costly for the society than to act on a preventive measure. Very likely, similarly, for chemicals, it is very costly to analyze a product and to know what are the different type of chemicals that are being used in these plastics, rather than starting from the design phase. So. On recycling, because it's really posing a question on recycling, maybe would you like to say something on design, please? Sorry.
Okay. So thank you very much also. I think we have already have the answer from the room that priority should be on the design and productions. Yes, I think we have so many experts here, and I think that's the right choice. From our view, it's because we see the presentation of the two speakers here that we have like 1,300 kind of chemicals in plastic. Is it necessary to have so many kind of chemicals? That's the first question. I remember that one of my colleagues also carried out research, and they find out only in the packaging materials, plastic packaging material, there are about like 140 something hazardous chemicals inside the packaging materials. So that's a question. Do we have to use that kind of toxic chemicals in the packaging material, even for food packaging? So because at the end of the pie is maybe too late or too costly. First to understand it and then to clean it up. So I think the design should be the first priority, is the right choice. We also know that in the production of plastics, production live plastic, there are so many steps from the virgin plastic and also from recycling materials. And it can, unintentionally, absorbs chemicals, toxic chemicals. We heard about PBD, that's intentional, but also unintentionally chemicals. PCB is also unintentionally toxic chemicals. So it's a production line also the second priority. And of course, because we are facing the huge amount of waste, so maybe the last priorities is also one of the concern here that people the audience in the room pick up is on the recycling. That's the end of pie treatment. So,
thank you. So you picked 3 priorities, but they were allowed only 2. So maybe if the room was allowed 3, the end of life would have grown higher as well. Just conscious of the time, may I ask just very short answer for the 2 following questions, so that Mr. Nguyen also has time to develop on the policy dimension. We can go maybe for the room to the second question, which is, please enter, so think first, and then enter only one word. Actually, I think you can enter 2 times one word that represents a priority for action for addressing chemicals in plastics, in your view. And maybe on that, while the room is thinking, we could just cover quickly the issue of recycling and of tracking chemicals, having information on chemicals and additives that are contained in plastics, as well as how do we support and adapt the recycling processes at the moment. And probably it would be really nice to maybe touch upon wastewater treatment and microplastics at the same time, so we gain a little bit of time. Dr. Chen, would you like to speak about recycling?
Yes. In fact, from my point of view, for recycling, we have technology. In fact, mechanical technology and energy technology we have. In fact, for the mechanical recycling technology, from the problem feedback from the industry, this side, the sorting is the big problem. If the plastic is very pure, so it's very easy to recycling. But for the mixed plastic waste, they don't know how to deal with. At the end, maybe they will be through or incineration or disposal landfill. And for the we all know plastic have the thermal plastic or thermal set plastic two cans. For the thermal plastic, it can be recycled by mechanical technology. But for the thermoset plastic, such as the printed circuit board waste, it's very difficult to recycling the non-metal powder. As we all know, the PCB waste, which is printed circuit board waste, it has many kinds of heavy toxic chemicals. It has heavy metals, has the pulps or other organic chemicals. So for these kind of non-metal materials, I think it's the key is to develop the new technology. Okay.
Okay, thank you. So, in terms of recycling, from that question, I could think from, I remember from this morning when we heard the presentation of the transboundary movement of waste from one of the world to the others. And we could ask the question, why it's come to China before and now when China imposed a stricter regulation, it come to Southeast Asia. And then when we, try to ban it, then it will come somewhere else. So why is that? Is that the demand of the recycling plastic? Yes. But why is not recycled in the developed country? We come here. Yes, that's the question.
That's easy. That's easy to answer.
Yes,
it's the price.
The
same question was last time at the conference of parties,
yes.
And then one recycler from US stood up and said, "Okay, 1 ton is $70 recycling." And in Europe also, when you incinerate the plastic in an incinerator, it goes €80, €100, and it seems it's cheaper to send it to Vietnam.
Yes. Okay. So I will continue that story. Why is it cheaper? Is it because of only the labor cheaper now? No, it's not enough, right? Is it because the environmental requirement or standard lower? Maybe. Maybe is it because the enforcement weaker? Maybe, right? Maybe because of the environmental or standard for products lower? Maybe. So there are a lot of reasons that make the recycling in the region now, and maybe moving to the other region in the futures. And from the job presentation, can we really tracking the toxic chemicals in the supply chain from the virgin plastic to products and then to raw material and recycle and then go back? The cost going to be really high in every way, especially in developing countries like in this region. So I could think that in order to do so, we need to think of the whole life cycle assessment process, the supply chain process, the value chain process, the environmental standards, the capacity to actually tracking it, or to monitor, or to analyze the end product or the new product or recyclable products. So with all that, then we can do the proper recycling. Otherwise, we will face a problem still.
And internalize their externalities like environment and potentially health costs. You want to react, Roland?
Really the information need to be better in the supply chain. We see, for example, with the PBDEs, the European car producer said, we don't know. We don't know if we use the PBDEs. So the companies which were delivering the plastic with the additive, we did not ask what additives are there. Yeah, this has changed. So we have some now, the big companies, they know what chemicals they have. And I think also they will be able, Sony, to take back the plastic and recycle. So there has been an improvement, but this should be global. Yeah, that there is at least in the supply chain the information on the additives in plastic.
Yeah, regarding the recycling and also the sewage treatment you asked, we found the chemical fibers in sewage treatment, the sewage effluent after secondary treatment. Some portion of the chemical fibers can be removed during sewage treatment, but it's not perfect. We found the chemical fibers in sewage effluent, and some companies, also some NGO, encourage the recycling of the PET bottles to be T-shirts. But it's not the good way to recycle. The recycling leads to the chemical fiber pollution in rivers and finally the ocean. So we have to think over the fate of the recycled materials.
Thank you. As T-shirts are being washed and therefore release some microplastics in the rivers and in the oceans. So, looking at the beautiful word match, we have regulation and enforcement, which seems to go very much together. Research, a lot of research is still needed indeed. Transparency, and you mentioned it, Roland, knowing what is in the product is a first step. Education, technology. On the side I see reduce as well, and I think that was also a message from Roland's presentation and Professor Takada's presentation. If you reduce the amount of chemicals that are being released at the same place. Maybe we can move to the third and last question for the audience, which is a bit more thorough than the other two. If you could share with everybody in the room your solutions to prevent chemicals and additives of concern having an impact on the environment, and as we've seen, potentially on human health as well. In parallel, I would like to ask Dr. Nguyen to comment from a policy perspective. What are the lessons learned at the moment? And hear from the rest of the panel their comments. Can we make it quite brief, please?
Okay, thank you. So I think we already again have the answer from the room that regulation is more important, and then enforcement. And from the information we got, we could see that first to develop a policy or regulation, we need to understand the problems properly. So and from the chemical in plastics or in products, then we still have I could say really limit information or knowledge to really understand the problems. Maybe we have problem with the additive, we have problem with the unintentional chemicals that introduced in, we have problem with the macro side plastic and also the micro side, micropit, microfiber, and each of them will have different kind of impact, and then it requires different kind of policy and regulation and implementation. So I think that's the first thing that we could think of from policy development perspective. The second one is on what really situation that we have to face now for the short term and medium term and long terms. So for the short term, it should be a priority. Does that mean that the situation now is toxicology is high enough to really make impact on the human health or ecosystem? If the answer is yes, then we have to do something now, or it's too late. Or maybe if macro side plastic, it should be easier to do and it make bigger impact, then we should get it priority. So the second issue should be the real situation, because we have huge information today, too much, and then setting priority depend on the situation we face and understand it should be the second one. And then we can think of the policy option as a voluntary of enforcement. We can use the framework of SICOM or Basel Convention, Stockholm Convention as a guidance for national framework or regional frameworks. Or we can choose the multi-sectoral platform, or we have to focus on something really urgent. So I think that's a policy option, and then we can go on with the evaluation and implementation and continue with that circles. So that's what are good things. Thank you.
Thank you. And could we just click on the arrow of the screen, because I see get rid of the environment, and it remains here as a solution. I don't know, somehow it makes me a bit uncomfortable. So yeah, just to get an overview of some of the responses: regulate the type of chemicals and additives, strongly reduce plastic production and consumption, separate and sequester existing plastics with additives, eliminating additional additives, and of course, don't use plastic to begin with. Yeah, so you can just see the different, avoid buying unnecessary items. Do you want to comment either on that, on the policy dimension, and maybe we have then a few minutes for questions from the floor, if there are any. Very limited time.
Yes. But I mean, the last sentence, what you said, is just what I said from the late king of Thailand. It's sufficiency economy. Yeah, I mean, we have a footprint here in Europe of 4, so we have to reduce. And I mean, what not better to start to reduce what we not need and at the same time harm the environment? I mean, single-use plastic, for example. And another thing is, what I like is to put waste and recycling as top priority. And here we have the President Lee, which said this year that waste management have to be a priority of the country. And I would like to hear this from other presidents in the world and really put this as a priority. I think this would solve a big part of our problems.
Follow Dr. Roland. President Xi's thought on the ecological civilization construction. He mentioned to build community with a shared future for mankind, and to establish a legal and policy framework that promote green production and consumption, and the low carbon and circular development. In fact, regarding to the legal and policy framework, China is doing a lot of work in recent years on plastic, on marine litter. In fact, for the plastic or single-use plastics, the trash sorting activities, it's ongoing in China. There will be 46 main cities finish the demonstration activities by 2025. And now China has the zero waste city pilot construction. By now there are 11 plus 5 demonstration cities or regions. Yeah. By the end of next year, all these 6 cities or regions should finish the indicators to construct the zero waste city. Yes. The other one is a wide pollution control program. In fact, in the morning, the friend from the Northwest Pacific Action Plan, the friend mentioned the zero waste city construction in China and single-use plastic pollution control at the city level or provincial level. In fact, at a national level, there will be regulations soon. Yeah, issued.
Thank you. Professor Takada, you'll have the last word.
Yeah. I have the more specific 2 proposals. One is the phasing out of the landfill as soon as possible, and another the suggestion is to separate or segregate plastic waste from the organic waste. The first proposal is based on our bad experience in Tokyo, which I showed on my presentation. Even after stopping the landfill, leachate is still running and it still contaminates the river. We, Japan, put so much effort, technological effort to reduce the contamination from the landfill leachate. But even after such the huge technological effort, we still do contaminate the rivers with the BPA. And another proposal is the reduction of the segregation or separation of the plastic waste from organic waste, such as kitchen waste. Under the organic waste produce the anaerobic condition in landfill site. Under anaerobic condition is some additives can be converted to the more toxic compounds to prevent such the generation of more toxic additives byproducts. We have to separate or segregate the plastic waste from the organic waste. That is my proposal to Southeast and South Asian countries. Thank you.
Thank you very much. So we will all use our composts. Thank you for the panel, and we'll hand over to the conclusion.
A round of applause, please, for our panelists. Thank you very much, Sandra, for facilitating this panel. All right, ladies and gentlemen, I am about to invite on stage our conclusion, somebody who's going to bring about the conclusion this evening. It is Jyrka Tamalanda, and he's going to wrap up the event for today. Unfortunately, I have to leave for a flight. It's been wonderful to be here. I do have one thing that I would like to just put out there. You know, I have been speaking on the environment since 1996, and I have been a UN EP Goodwill Ambassador for quite some years now. And even I have learned some things today. You know, and a lot of things, there are things that I know about the issues with plastics and transboundary issues and the problems that we have with plastics in our environment. But I implore you to find ways to make it for dummies. Okay, science is amazing. Science is amazing because that's how we set our barometers and that's how we set our course. But we need everyday consumers to understand the severity of the situation. And unfortunately, they don't get to sit in this room like I do and understand what's going on. So I really do implore you, first of all, make your language super simple. Second of all, find people of influence and get them to understand the story and get them to be your mouthpieces. Get them to share the stories and give them the power or empower them to do so. Anyway, that's it from me. It's just a simple message, and I hope that it resonates. And I hope you enjoy the rest of the week here at the UN. Thank you so much for having me as your host. And I'd now like to welcome Jyrka on stage to wrap up. Thank you so much.
Thanks very much, Nadia, for that. And so as not to lose the opportunity of saying this when you're still in the room, thank you very, very much for your input here. We really appreciate it. I think we also should really listen to some of Nadia's advice. She interacts with a lot of audiences much beyond this room, and I think it's good advice for us in terms of reaching out with a message to a much, much broader audience than what's in this room. So very much appreciate your personal reflections on this, and very much appreciate your work as one of our Goodwill Ambassadors. So thank you so much. It's 4 minutes to 5, which gives me precious little time. I will keep you for that extra 10 minutes that we lost this morning. Let me also start by saying that I'm not going to go through everything in detail. You heard it today. I assume you still remember it. So I'm going to try to just summarize a few of the main things that I felt came out of this. More about the general content than the specific recommendations. Needless to say, our attempt here will be to really capture the main messages emanating from all of the sessions we've had. What were the key findings, key issues raised, recommendations made, and make sure that we capture it here. This was just the first day. This is the day on science and the foundations for better decisions, for more and better action. We still have a couple of days to go. So let's see how we can carry forward all the wealth that was brought into discussions here and digest it even further over the next few days, and then synthesize something that speaks with the collective voice of those who are here. And that's maybe what's a bit different to what the UN often does, is that it's quite very, very multi-stakeholder in terms of the engagement, in terms of the input to the panels, and indeed it also becomes quite a lot more useful to use as a collective document, whatever it is that we produced at the end of these 4 days. We have had the benefit of hearing from a lot of experts, from within the region in particular, and I think that's very heartening to see how strong the science is here and how much there is to build on from within the region. At the same time, we've benefited greatly from input from individuals and institutions outside Asia that have brought in valuable reflection on how things may have been done at the global level or in other regions. And in fact, this is one of the key elements that we need to get better at building on. This was certainly one of the findings from the sessions today, is just how do we get better at managing all the knowledge, all the information, all the data that actually does exist, so that we can put it to use more effectively than we do today. Starting the day, we had the benefit of hearing from Dr. Wijan, and I have to say, again, speaking from the perspective of COBSI and UN Environment, we've had the benefit of drawing on his expertise on many occasions in his job as permanent secretary, certainly, and we're very, very happy that he agreed to be here again in his new capacity as president of TEI. It's been a good partnership, and his experience and expertise has certainly helped address these issues, not just in Thailand, but certainly in the region and through ASEAN, so we should recognize that contribution very much. The sessions today, as you will have seen, they were an attempt perhaps to look at how we can create more integration and not compartmentalize too much the challenges of marine litter. It cuts across all aspects of society, everything we do, so we need to be really, really integrated in how we tackle the issue. This also comes out in the discussions, and this is where I will not reflect on the specifics of each session, but only to say that in the gender and human rights session, for example, earlier this morning, where also a new report was launched, and I draw your attention to that. It should be available on our website now, which really describes what we currently know and where some critical gaps are in relation to those two very important aspects of marine litter here. This session spoke very much about chemicals in and on plastics, and how maybe different stakeholder groups have different vulnerabilities to those. And of course, that ties very much to what you heard here at the end of the day, where we can see, yes, chemicals in and on plastic is an enormous agenda in and of itself. You need very particular expertise to move that agenda forward, but at the same time, we need to get that knowledge into the shape where it can be really owned and taken to heart by individuals that make consumer decisions and by policymakers that develop new regulations at the national level, or where they actually come together and set much clearer standards and regulations at regional and global levels. Clearly there's much work to be done in that space. The chemical sessions here also, of course, it invariably discussed many of the aspects that drive the international trade in plastic waste, including illegal trade in plastic waste. So the chemical dimensions of plastics are very important to understanding how we can address trade issues of plastic. And trade has been a particularly prominent discussion item in this region over the recent couple of years. You all know that very, very well. If we don't have an understanding of the things that really drive the trade on many levels, if we don't have an understanding of many of the governance challenges at many levels, then we're not going to be effective in addressing trade. And that actually brings me to the point about the governance discussion. So, of course, the trade session spoke much about governance frameworks, which was a discussion item on its own, where we looked at how the global current policy and governance framework actually looks at the global level, at this regional level, and touched on the aspect of having such a multitude of instruments that sometimes are quite broad and all-encompassing, sometimes very, very narrow and very specific. And if I would lift out one of the conclusions there, it's not to say there's one right answer, we must simplify and do away with much of this. It's more to say that we do have a lot of processes that are there for a reason. How are we able to make better use of them and ensure that they work in unison and pull more in the same direction than perhaps has been the case before? Last, certainly not least, in the governance session, we also very much recognized that governance, policy, regulation, management, action, and so on, at the end of the day, it's driven by good knowledge, good facts, good science, good data. And we do know a lot. There is a lot of research. There is a lot of science in the region. At the same time, we know that much of the data we need on ecosystem impacts, much of the data we need on leakage into the environment, the transport of different plastics, their ultimate fate, it's not at a level where we can actually say this is how it will reflect in society at every level. Our knowledge about the health impacts of plastics and the chemicals in and on plastics are not at a level where we can say these are the ultimate societal ramifications. So these are challenges for policymaking. So we do recognize there's a big piece of work to be done in order to move policy agendas forward globally, regionally, as well as nationally. So we can see how those questions will be dealt with and answered to some extent over the next 2 days. I think that will be very interesting. If we speak about this as a scientific discussion, it has been to some extent, it has been much more than that. It's always good to listen to the customers of the products we produce. Who uses this data? Who uses this science? Who uses this knowledge? Let's try to provide it to them in the format that they can really, really make use of. I don't want to dwell on that very much further. Let me re-emphasize again, we'll capture the real findings and recommendations, not my generic reflections on that in some form of outcome document here. We'll try to make sure we carry those main messages into the 4th day of the forum so that we squeeze your intellect and work out of this week. And of course, we'll see how we can catalyze more action, more voluntary action. And actually, at this point in time, I need to invite another speaker for a few minutes of reflection, because I'm sure you're all familiar with the extent of voluntary commitments that have been collated in different fora. The Clean Seas Campaign, beat plastic pollution, our oceans, the UN Ocean Conference, voluntary commitments, and so on. We have a big pool of commitments made by a very wide range of stakeholders. And I think at this point in time, we'd like to invite some reflection on how those different commitments actually add up and how we can make more use of voluntary commitment in terms of driving this really significant change that we need to see. And I think I can go back to Isabel's words this morning when she said we need to go from incremental change to really transformational change. So can we use incremental actions to drive transformation? So Doug Woodring, who is the head of Ocean Recovery Alliance, has done an analysis on this, which is a job done together with UN Environment, responding to the UN Environment Assembly resolutions on marine litter. Doug, are you in the room? This would be a good time to come here. Okay, there you are. Wonderful. I'm putting you on the spot. Can you tell us about the analysis you've done? Can you tell us how to make more of what seems to be a really good pool of potential?
Well, thank you for that. And I just want to make it couple of comments at the very end. The message was made about being simple and translating that message into something that the rest of the community that you work with can be easily discernible and understood. Takada-san mentioned that separating plastic with organic would be very important for the regions of toxicity and leachate, and this is something that we have been promoting for a long time, which is just sorting by wet and dry. And if you do that, not only can you achieve what Takada-san was talking about in terms of leachate and toxicity, but a much easier way to sort and recover material in any system of handling by hand or technology if it is not mixed in with household and organic waste. So there's many, many benefits with doing something very simple. So we were asked by UN Environment about 18 months ago to look at 580 commitments that were made by the private sector, government sector, and the community to see how those plastic commitments have come through to mean something for all of us as a global community trying to reduce plastic pollution. That was about 5 years of when those commitments were made, and we created a scorecard and a toolkit to show and try to evaluate the power and the transparency and the value of what those have done. What we found actually was that a lot of them didn't mean very much. And that's not necessarily to try to call anyone out that they did a bad job, but in many cases there were commitments made without a lot of thought and a lot of maybe not funding, maybe they didn't have resources, maybe they didn't have easy replicability, and so it was not something that the rest of the world could take to value and build momentum on for others to use. So we created a toolkit and a way to evaluate either existing commitments, so you can score to see if your commitment was valuable, but also going forward, if you're going to make new ones, whether you're a government or a private sector, an NGO, and you say, I want to reduce waste, I want to reduce chemical input, I want to recover material, I want to change the way I design a package, you can now pre-evaluate and score that kind of commitment with a couple key things in mind. One is magnitude. Doesn't matter if you're a small entity or a huge multinational or government with a lot of resources, how much will your commitment make in the community you're trying to serve? And if you look at it in that way, can it be then replicated by other groups? And so velocity is the next one that has a very important angle. Velocity is the speed at which you can make your commitment become a reality, and which you can get from that goal to something maybe beyond the goal and make it bigger and then share it with maybe others in your industry peer group or others in another country. And we have the summary report. This was published by Ocean Recovery Alliance, but it was made possible by funding from the UN Environment. I have some copies out front. It's just the summary of how these commitments can be used. And so in the next 4 days, with all of the discussions, tomorrow is plasticity, all kinds of business solutions that we will be having in this room. Maybe you and your constituents can think about coming out of this 4 days, how you and your peers can make great commitments for the next 5 years. Thank you.
Great. Thank you very much, Doug. I would encourage you all to really look at the findings of this analysis and especially think about using these tools that actually are at our disposal to see how can we take our action that bit further. It's a little bit of extra effort, but it might actually mean quite a lot down the line. So every individual bit on addressing marine litter counts. Yes, we all know this. Every action we take as individuals counts. We all know this. some of what we do can do a lot more good if we approach it slightly differently and spend a little bit more time on thinking about that. I think that's a very, very helpful sort of piece to come out of these voluntary commitments. With that, I think we really should call it to a close. It's already 5:10, and we don't want to tire you too much on the first day. I have a few more things to say, one being, of course, a very, very warm, heartfelt thanks to all of those who have contributed to today in terms of organizing sessions, to speakers, to discussants, to all of you who have engaged from the floor in discussions. Thank you very much for that. I think we're looking forward to even more lively discussion in the coming days, and I look forward to working with all of you to really make this event as useful as possible. We welcome your feedback on this. We welcome your feedback on how we can capture things that you weren't able to discuss over the last hours in this room and in the room downstairs. We recognize all questions couldn't be addressed here. So please do submit to us those things that remain unexplored so that we can find ways of dealing with that also going forward. With that, I think I'll call it to a close and simply to say, please be back here again tomorrow for plasticity, which should be very, very exciting, a very different angle of attack for the marine plastic litter problem, and certainly a very important part of solving some of the most tricky challenges we have. Thanks very much.